Alrighty, welcome to Semester Exam Review 2017, Spring 2017, Part 5. Because, well, why not? We can have more parts as we want. Anyways, alright, I'm going to omit problems 116 through 123. I feel like we did test over them. We did have questions with them, but just for the sake of time, I'm going ahead and eliminate them. Alrighty, so then let's look at problem 124. Okay, so problem 124 talks about exponential functions, and in actuality, it looks like a good portion of these problems are going to do the exponential functions, and we're going to move into logarithmic functions. Okay, so what would be helpful here? This would be where it's helpful to have your powers table. So like you could see here that let's say 2 squared is 4, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th is 128. So that means I can put here 2 to the 7th instead of 128 and 2 squared times x. And so that would mean I can drop the bases and say 7 is equal to 2x. So then that x must be equal to 7 halves. And there you go. Okay, apparently Robin decided he's thirsty, so you might hear him like drinking in the background. But anyways, for number 125, 4x plus 1 to the equals 32. Again, you could look at your power space and you would see that 4 is 2 squared, and we still have the x plus 1. Notice that I put that in parentheses. And 32 is 2 to the 5th. So that allows me to drop the 2's and say 2x times x. 2 times x is 2x, 2 times 1 is 2, equals 5. Notice how I've dropped the 2, the bases. And then I can subtract to get 2x is equal to 3, and then divide to get x is equal to 3 halves. And there you go for that one. Problem number 126. If you can find your notes on this, this would make this a lot easier that we did on this, where you did those power bases for your, say, note card. Because again, you can add this to your note page. But we would easily recognize that 1 over 27 is 3 to the negative 3 power. Because remember, all those fractions were negative powers. So then I can drop the base and say x is equal to negative 3. And it is just that simple. Wow, wouldn't it be nice if Mr. Pash did something like that? I have no clue. Alright, so I've got here 1 over 32 is equal to 2 to the 1 minus m. 1 over 32 is 2 to the 5th. Well, 32 is 2 to the 5th, but the 1 over makes it negative 5. Remember, those fractions make them negative. So 1 minus m. So this would become negative 5 is equal to 1 minus m. This is the one where I like to still do the variables to the left, numbers to the right. So that would give me plus 5, a plus m. So I now have m is equal to 6, and I am done. That's it. So there you go. Problem number 128. Problem number 128, you could easily see that 81 is a power of 9, but maybe you don't have that on your table. Maybe you would have 3's. So a couple of different ways you could do this. If you recognize that 81 and 9 are powers of each other, then you'd have to recognize that this is 9, 1/9 is 9 to the negative 1. Okay? And then 81 would be 2 or 9 to the squared. Okay, so you can work it like that, m plus 4. And then that would give me negative 1m is equal to 2m plus 8. M's to the other side, we get negative 3m is equal to 8. Divide by negative 3. And m is equal to negative 8 thirds. Okay, you can do it that way, or you could also work them as powers of 3. Then you would have had 3 to the negative 2m and 3 to the negative 4. 3 to the 4th power, and it still would have come out just with slightly different numbers. Number 129. Okay, so number 129, we should recognize that 25 is 5 squared, x equals 5x squared minus 15, and thus I can drop the base saying 2x is equal to x squared minus 15. Move the 2x over, and now I'm saying that 0 is equal to x squared minus 2x minus 15, which again, I'm telling you, every single time you see these type of problems, quadratics, cubic, whatever, and they're set equal to 0. I mean, we can solve these by factoring, But let's stick to one method. You can also solve them by graphing every time. And if you graph them, if you were to graph this, you would get a problem that would go through, let's see here, 1, 2, 3, 4, 5, 1, 2, 3. That is like the worst drawing of that. Let's try that again. Yay! Look, I crossed the line. Woohoo! There we go. All right, so that would tell you that x is equal to positive 5 and negative 3. Or whichever. And that should be it. All right, so there you go for that. Okay, starting at 130, we start seeing some logarithmic, exponential. I mean, these are like the next extension of the exponential. So let's look at 130. And you've got 12e to the 3x minus 2 power equals 8. Okay, the idea again is to always get the e by itself. So I need to divide this by 12. And you would get e to the 3x power minus 2 is equal to 8 divided by 12 is 3/4. Then remember, you can always, to get rid of the e, we had this in another section, put the ln. ln and e's cancel each other out, leaving you 3x minus 2. Okay, so if I do the natural log of 3/4, I get a decimal of, say, negative 0.28, okay, rounded into nearest thousands. So 288. Okay, obviously I'm going to add 2 to that. So I'm going to say plus 2, and then 3x. And notice this becomes just like a normal two-step equation after a certain point. So I have now, right now, 1.712, and then divide by 3. And I get an answer of x is approximately equal to 0.571. Okay, for problem number 131, we want to make sure that we isolate the natural log. A couple of different things that we could do with this. I think the easiest thing to do would be first make sure that we try to get x by itself, or the natural log by itself. So the first thing I would do is go ahead and subtract 1. Okay, always start off with something like this. Now, the idea is if we can have this down to whatever it is by itself, that would make things a lot easier. So, let's do something like this. Let's put the 2 out here using the properties of the logs. Then we can get rid of the 2 by dividing. So now I have natural log of x is equal to 1/2. And then I can do e. Remember, e and natural logs are always opposite of each other. And that would leave me with x is equal to e to the 1/2 power, which would be 1.649. Approximately 1.649. And good enough right there. So moving on to the next. 132, I'm going to admit that is a problem that I know we maybe done, but mainly I think more in notes than anything else. And I know there's nothing out like that on the test. So let's look at 133. And let's go with log base 12 of the 7n plus 12. I'm sorry, plus 2. Wow, I'm reading there, Mr. Patch. Anyways, equals log base 12 n squared plus 12. Well, I knew there was a 12 in there somewhere. Okay, go with that. Anyways, notice that these are both the same logs, same base. The logs by itself, in a sense, on each side, so I can go ahead and cross things out and say 7n plus 2 is equal to n squared plus 12. Since this is an n squared, this is a quadratic, everything needs to move over to the side of that. So I would get 0 is equal to n squared minus 7n, and then I have 12 minus 2, which would give me 10. Again, you could graph that fairly easily. I think that's the easiest thing to do. I mean, we could factor it, and you should get that, say, answers at 2 and at 5 for that answer. So that would tell you that n is equal to, say, 2 or 5. Okay, so now I'm looking at 134. 2e to the x is equal to 4. Again, the idea is always get the logs or the e's or the natural logs or whatever by themselves and then worry about what I could do to do the opposite. So here, divide by 2, and you've got e to the x is equal to 2. Okay, now that I've got the e to the x by itself, I can say natural log. That way these cancel out, leaving me x, and I'm basically just looking for the natural log of 2, which is 0.6, approximately 0.693. Okay, so fairly easy, nothing too difficult there. 135 is pretty much the same thing. I've got e to the 3x is equal to 124. So again, take the natural log, and that will leave me with a 3x is equal to the natural log of 124. Get about 4.820. I can divide by 3 and get x is approximately 1.607. 1.607. And that's really about it for that. Okay, so here's now an example of kind of going the other way. I want to get rid of the natural log. It is by itself, so I can go e and e. That way these cancel out, leaving me 2x is equal to e to the 4th power. And then I'm going to divide that by 2 to get what x is equal to. So here I've got, say, e to the 4x, or e to the 4th, I'm sorry, and then divide that by 2, and I get my answer, which is approximately 27.299. Alright, 137 is probably a lot easier, or a lot simpler, or a lot similar to the 132, but for some reason I feel like that one's simpler. Okay, so just the way like e and ln cancel each other out, because technically ln is log base e. So logs and their powers, their bases kind of cancel each other out. So I can do the same thing here. I can say like log base 10 of 10 to the 2x will cancel out. Those would, but if I do that on one side, I've got to do it to the other side. So log base 10 of 8. That way these cancel out, leaving me the 2x is equal to whatever answer log base 10 gives me. So when I type that in and say 10 and 8 here on the calculator, I get 0.903. Yeah, I did say 0.9, not 0. Whatever. 0.903. Okay, and then divide by 2. So you see, a lot of this is just getting through that first step. And then once you've got that, I mean, really none of this should be that difficult. It's just a matter of, say, applying. I get, by the way, 4.4515, which means I have to round off to 0.452. All right, so let's look at the next one. And so I've got one problem, 138. Hey, we're chugging along now. Let's see here. We've got 3 to 2x minus 3 power equals 7. Same idea. Always take whatever the base is. So I'm going to say here log base 3. Log base 3. So now I'm saying I have a 2x minus 3 is equal to log base 3 of 7, whatever that might equal. Okay, so again, you type on the calculator log base 3 of 7, and I get 1.771. So now I'm not worrying about this, and now I'm going to add 3 to that. So I'm just doing what we normally do, and then I'll divide. So I'm going to add 3, get 4.771, and then divide by 2 to get what x should approximately be equal to. And I get 2.386. Okay, so you can kind of see how that works. Hopefully it shouldn't be too difficult, but always make sure that like the 3 is kind of, or like the base is kind of by itself. So like if you look at problem number 139, 4 to the 3x plus 2 is equal to 3. Notice here, this is not by itself. So I have to subtract the 2 first, then I get the 4 to the 3x is equal to 1. Then I can say log, but base 4. Remember, it's always whatever number you see right there. That will leave you with a 3x is equal to whatever log base 4 of 1 is. And hold up. I can't believe I didn't realize that was 0. I'm slow today. So, and then when you divide by 3, you get 0, because, well, anything to the 1 power is 0, but that's a whole nother story. Okay, so let's look at 140. Same idea. 5 to the 2x plus 7 is minus 1 is equal to 8. Add 1 to both sides. You get 9. So now I'm saying this is 5 to the 2x plus 7. I can say log base 5. Log base 5. That way this cancels out, leave me 2x plus 7 equals whatever log base 5 of 9 is. So when I type that in, base 9, I get 1.365. Okay, and then I'm going to subtract 7 from that. And this is really easy because all you got to do is like keep typing into the calculator and you just keep getting your answers. Here I've got negative 5.635. And then you divide by 2 to get x is approximately equal to, divided by 2, negative 0.2817. I don't think I gave myself much space on 142, but oh well. Alright, so here we have this one. Always remember, if they don't tell you a log, it's base 10. So I can go like this, 10 to 10 power. That way these cancel out, leaving me x minus 25 is equal to 10 squared, and 10 squared is 100. Then I can just add the 25, and I would get that x is equal to 125. Remember, these you're not supposed to be able to get negative answers because negatives cannot count with logs because, well, we can't have a domain of x. Apparently, it is not a good idea for me to be in the same room with a guinea pig and the cat outside. Anyways, all right, notice on 142 that the logs are the same, so that way these cancel out. Leave me v squared minus v is equal to 48 minus 3v. Again, quadratic, so we move everything to one side. I'm going to have a plus 3v, so I got v squared plus 2v minus 48 is equal to 0. Now this one might be a little bit, no, it shouldn't be harder on the graph, but if you do graph this, you would get something like, this was logs, so I would get v is equal to negative 8 and 6. Now again, we can't take the negative answer, so your answer should just be 6. Because remember, the domain for logs is positive. Penalty for this round of the parts or the video reviews, we're going to say here log 3 base x. Again, if I do a 3 here and a 3 here, that will cancel out, leaving me just an x. So really all I'm looking for is 3 raised to the 2.5 power. So I say 3 raised to the 2.5 power, press enter, and I get approximately 15.89. 15.589. Okay, on the other one, minus 6, I've got to say go like this. I need it, before I can do the log, get rid of the log, I have to get rid of this minus 6 because I need this log by itself. So really now I have log base 4 k plus 9 equals 3. Okay, so raised to the 4th power, raised to the 4th power, that gives you k plus 9 is equal to 64. And then you can subtract 9, because remember, these cancel out, leaving just that k plus 9. And you get k is equal to, what, 75? No, 55. What was I thinking? I'm a little slow today. All right, and there you go. So, again, this hopefully was just a quick more review of some of the logs that we had covered before. Hopefully you can remember these properties. I would make sure I have them on my note page. But there you go, and that's it for today. Or at least that's it for this one. Thank you so much. Y'all take care.